So what we are going to see today is an addendum to the course, which covers the topic of monads. Now, okay, so as you may have noticed, there are some very recurring patterns in the code that makes up a compiler. So, the lexer, for example, how does it work? Do you remember the most recurring patterns in the lexer? I'm gonna open it. Oh, wait a second, this is not the lexer? No, it isn't. Oh, well, I can show the type checker. Doesn't matter that much. So, look. Take a look at type check, for example. What do we do with the context of the type checker? Every call to get type and type check s is from the lecture of last week. What does it get as parameter?
Get type gets expression and context.
Get type gets an expression and
Context.
and the context. Yes. And once again, context. Once again, context. And so on. Now, there should be interpretation as well here. Yes, eval. Look at memory now. Every time we call eval again, what happens? What does it get as parameter? The memory itself. Yes. Now, let's look at eval s. Eval s has memory here, and whenever eval is called, obviously it has the memory, the current memory. Look here. Do you see potential for mistakes? I'm going to zoom this. Look here. What are we doing?
You're putting the things in front and behind the semicolon.
Yes. But specifically, what's happening to m? So every call of eval s has an m. Yes. Which one?
The original.
Not the original,
No.
because m only happens in the first call. The first m that is given to eval s at line 92 is the memory, the current state of the program. We eval this statement. After the evaluation of a statement, memory has changed. So what we get back is a new memory, which is called m prime. Then, is this memory relevant? No. Which memory is relevant now? M prime. So we give m prime to eval s. Then, suppose we had a double semicolon with s1, s2, and s3. Sorry? Yeah, but the point is, we would have now m second, which would be given to eval s, m second of s3. This would produce m third, which would be the final result. Notice that here, with the evaluation of the if, we have the very same thing. So the way memory goes through the computation, similarly to the way the context goes through type checking, is actually always the same. The goal of this lecture is to find a way to automate, to capture and automate patterns of code usage such as this one. Let's go back to an even simpler example. A file opener, a file processor. So let's see. Open file. What is the signature of open file? I'm not actually going to run this. But what is the signature of open file? Sorry? Or better yet, read all lines. What's the input? The file? The file path. So path has type string. And what does read all lines return? A list or string? Oh, very weird. Not implemented. What if I told you that no, I don't like the return type because the file may not exist. And if the file doesn't exist, what do we return? Sorry?
Empty list or no?
And
Yeah.
okay, so he says an empty list. What's the problem with an empty list if the file doesn't exist?
Could also be an empty file.
It could also be an empty file, right? If it's an empty file, do I want this kind of confusion? If it's an empty file, maybe I should not give a result. I should say the file didn't exist. Sorry, if it is an empty file, I want to process it. If it is a non-existent file, I may want to simply say no, it's a non-existent file. So how do I decorate this type? What do I need to add to be able to say I have no answer?
Should be some or none.
Yes, and the type that contains some or none is
Maybe.
option.
Yeah, it's
So option of list of string actually can be some for a result or none for no result. So we can do if let's see, system.io.file.exists path, then well you know what, some laziness helps in life. File.read all lines path. Else, oh, somewhere, yes. So I encapsulate the read of lines result into a constructor that actually says, here's a value. I have a value, I have a result. Otherwise, none. Now he's going to complain because this is an array sequence dot list. Yes. So the moment where all the red disappears is actually slightly pleasant.
yes.
It's now connected to a slight release in endorphin in my brain, which I can actually feel. So I like it. Anyway, okay. Now let's convert to int. I want to convert a string s to an integer. Okay? What is the return type of the conversion? Is it an
No,
integer?
it's also
It's, I want to convert it to an integer. Now, can I convert every string to an integer? So, what's it going to be? It's going to be an option. I mean, let's see. Now, system.int.vars. Yes. Yes. Now, so what I'm trying to do is basically not throw exceptions, because exceptions can actually bite you very much in the ass. So if there is an error with the conversion, I return none. Otherwise, okay. So you see what I'm doing? I'm hiding exceptions. What is the biggest danger with exceptions? Assuming they could not be thrown. Have you ever
That's a
ignored?
waste of
That's
if you program an exception, then you don't want to.
So that's the point. If they happen, then they happen. So all exceptions should be handled, which makes code, kind of more annoying. So what I'm doing is I'm basically making a promise to myself. You can't read the list unless you check first if you do have a list. Now, let's say I want to convert list. Sorry, I'm going to give it a better name. Convert string to int. now convert list, convert strings to ints. What is the input of this going to be? A list of strings, yes. And what is the output of this going to be? We've been there already. What is the output?
A list of options of ints.
So a list of options of ints. Yes, okay. What if I say I want to convert them all? No, actually, you know what? We're going to keep this. Okay. So for x in L, we give convert string to int x. Right? This is still a correct formulation, right? So if one of them fails, it's not a big deal. Okay? Now what is the last step? Imagine that I really want to make sure that in the file there are only ints. Every line in the file is an int.
Check frames.
Yes, but okay. Convert all will take a list of this can be generalized outside of int. A list of option of alpha. No. So I want to say that if any of the elements is none,
Everything should be none.
then the whole thing should be none.
Then it should be an option of the list.
Oh, yes. Then it should be an option of a list of alpha. Now, this is a recursive function, match L with. It's going to be slightly annoying to write, as you will see. So if the list is empty, what is the result? Is it none?
No.
No, because it is a valid list with no nones. Okay?
Just return empty.
So I can try to return empty. There.
Some empty.
Some empty. Yes, exactly. Okay. If the list is not empty, well, I do have to make a check on this.
Check the sum.
Exactly. If this is none, then does it matter what excess is? No. So what do I return?
None.
None. If this is sum of x followed by excess, so the type of x, I'm going to write it, is alpha. And the type of excess is list of alpha. It is list of option of alpha. So, who can I give access to?
To convert all.
To convert all. So I'm going to do this. Let ys, x belongs to y, ys is equal to convert all of excess. What is the type of ys now?
Option.
What is the type of ys?
Option list.
Option of list of alpha. Okay. So it could be none.
Yeah.
So instead of doing this, we're going to do match convert all of excess with, if what we get is none, does it matter what x was? No, because there is a mistake later on. So we haven't found a mistake yet, but there will be later. So what we say is none. We just return none. If convert all is sum of ys, and what is the type of ys now?
Alpha. Yep. Option of.
No, the option we have unpacked already. Yes?
Is it now just a list of alpha?
Yes, it is just a list of alpha. Absolutely. So now we convert all tells us I have none or I have sum of a list of alpha. It is not none, it is sum, and what's inside is ys, which is a list of alpha. So what do I return? Actually, this is prettier if we call it y.
I.
Y and I, yes.
Some.
Within some, yes. Yes, absolutely. Okay? Now we can connect all these functions together. So, let my merry and safe, it is merry because it's very safe, there's no way we can make a mistake here. We are forced to match everything to be 100% sure that there is no mistake. There's no possible exceptions that may slip. Guys, this is an incredibly powerful guarantee. So we cannot break this thing.
Unless you pull the power.
Yes, exactly. So, my merry and safe file reader. Which is going to be a function. Now, let lines is equal to read all lines of file because it doesn't exist. So what's the type of lines?
Option of list of string.
It's an option of
List of string.
option of list of string. So lines is an option of list of string. It's harder than it looks to program and talk. Okay, so what do I need to do? I will now convert them. But can I convert them directly to a list of int?
No.
No, what do I need to do?
Convert all.
Convert all. Convert strings to ints of lines.
Isn't it?
And this is ints. He's complaining or not? No, yes, you will be complaining. Then ints, you say, is
Convert all. Well, what type is?
okay. Let's return whatever, and let's see if it complains. Oh, it is complaining
Okay, only one line.
because convert strings to ints. What type does it have? Convert strings to ints. Does it take an option as input? No, why not? Because it goes from the assumption that you give it a list of strings. But what we have is lines, and is lines a list of strings? Maybe. How do we know?
You need to check first.
We open the box and we check inside. So, and how do I check?
Mention the functions that's up there, but I can't.
So, no,
Scratch it.
I just match it. Match lines with
No.
none. In case of none, can I go on with the program? No. So print fn, sad face. You would probably need some proper error handling, but
No, it's fine. It's fine. Don't worry about it.
then sum, I'm gonna call this actual lines. Ugly name, I know. Now, what is the type of actual lines? A list of string. And now, what did convert strings to ints mean? So, okay. Now, what is the type of ints?
A list of options of ints.
A list of option of int. Yes. The program is moving horizontally also, notice. Now, convert strings to ints. What do we need to do? We want to add them all together. Yes, we will add them together. So, what do we do?
Convert all.
Convert all. What does convert all to? What does convert all do?
List of options.
It takes a list of options and
If it returns an option list.
it returns an option list. So,
Convert all ints.
yes, let maybe ints is convert all of ints. Let's see if it's happy. It is happy. What is the type of maybe ints?
An option list
An option of list
of ints.
of int. Okay. And now, can we add them together?
No, we need check if
We need to
option is somewhere.
match maybe ints with, if it's none, actually no, because we got almost there.
That's even worse.
Yeah, it feels even worse. Some, what do I have here?
X followed by XF.
Sorry?
X followed by XF.
No, I don't know. It may also be an empty list. Could also be empty. So?
So just
X followed by option.
No. What is the type of what I have here? Okay, I'm gonna write here XXX. What is the type of XXX?
this.
List of ints. List of ints. I'm gonna call them actual ints. Yeah, you quickly run out of names, you know, ints, maybe ints, actual ints. Okay, now, finally, I can say print fn %a sums to %d actual ints to actual ints given to the function sequence dot sum. Now, first of all, let's run this. Let's run do my Mary and say file builder. Oh, let's give it the parameter. This is the path. Ja, mensen en de net begonnen.
Mooi zo.
Okay, so yeah. What's gonna happen now if I run this? Do I get an exception?
No.
You can't.
Oh yeah. Just
Now let's go open bin debug. Now let's create a file ins.txt 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then two. You see now that here we make fun of it. So two.txt. We run it. What do we get? Look.
It's not.
I mean, seriously, it's and it's doing what it's supposed to do. We have perfect control over mistakes. Maybe I should not say that stuff before I run it.
Don't know how many lines.
We assume it's correct.
45. Huh?
It is.
it is correct.
Okay. I see numbers if my
45,
brain
yeah.
kind of shuts down. So, what is the fundamental consideration about this piece of code here?
Don't manage exceptions.
In terms of, is it predictive? No, it sucks majorly. Why does it suck?
Because it doesn't look.
Sorry?
You have to match every time.
Because you have to match every time, because you have to match too much. And actually something that also sucks is convert all. Because that kind of sucks as well, right? Now, I will ask you in the coming 10 minutes to discuss with yourselves a possible solution. Besides people who have seen monads already, then you may know. So I'll be back in 10 minutes. Right. We discussed the details later. Now, let's take a look at any of these matches. Now let's see one that's slightly prettier. Yes, I do like this one. I'm going to copy this somewhere else. Now, this is obviously the input of the match, right? And what is its type? So I'm going to rename it input. What is the type of this?
Option.
An option of?
Of this.
No, ignore the rest.
Oh.
So from what you see here, it is an option. So I'm going to call this function go ahead. The input, or no, try go ahead. So the input is an option of alpha. Then we match it. If it's none, then then we can't do anything. If it's sum of y, and what is the type of y? Alpha. Then, well,
You do something with.
I do something with it, right? So I'm going to say do something with y. Do something. Oh yeah. Do something is what? If it takes a parameter, it is a function. So it's a function, and it takes a parameter of type alpha. Alpha. So alpha goes into. Well, we know that this can return none, because do something needs an alpha, right? So, do something needs to return an option of?
No.
Does it need to return an option of alpha?
No.
Oh, we don't know. We don't care actually, as long as it's an option. This is also called bind. Now, let's see if we can actually rewrite this in a slightly different format. Oh, this is going to be challenging. Now, read all lines P, and what is the type of read all lines of P? Read all lines P. Oh, come on, it's written here. It's an option of something. So can we give read all lines of P to the function? Oh, I'm going to put it closer. To the function bind.
Yes.
So this can be the first value. Oh, I'm not even going to call it bind actually. I'm going to call it, I think I can do the weird operator.
Oh.
Yes,
Yes.
yes. Woo. Okay, so this is the left hand side. And the right hand side is going to be a function, because do something is a function. And what is the argument of the function? What's the type of the argument of the function? No, it isn't. It's a list of strings. So lines are list of string. And this goes into, well, a bunch of things. I'm going to return none now. Look, it's happy. It's accepting this. But within here, what we have available is directly, without matching, the list of strings. Can you see it? So here we had lines, which was an option of list of string, which then we had to match. But all this is now gone, because now we have directly the actual lines, and we don't even need to have weird names like lines or maybe lines or actual lines, whatever. We have the lines directly. So now that we have the lines, well, we could call convert strings to ints, right? Okay, so we have convert strings to ints of lines. What does this give us back? Let x equals x is a list of options of int, which we can give directly to convert all. And what is the type of this now?
An option of this.
An option of list. How do we get the goodies inside? With bind. So I bind, and this function, oh, so I don't need this anymore. Brackets get out of hand quite quickly. So what is the argument of the function of bind? The result of this, if it's not none. So what is the type of this? These are the ints. and this is a list of int. Okay, and finally, we can directly add them together. So I could say ints given to sequence.sum, but it's complaining because what do we need to return? We need to return an option. But here I do have a value, which is the final result. So what option do I return? Sum of the sum of these things. But I am actually returning the result, right? So I will write another function, which I'm going to call ret, which takes as input any value of type alpha, returns an option of alpha, and this is simply sum of x. I want to kind of hide the sum. So I'm just going to say return this. Okay? This is actually reasonably imperative now. So look at the code now, because it is actually significantly shorter. So this I'm just going to print. We lost a bit of control, which we could get back, but I'm not going to do it now. Okay, so this is actually, yeah, this is actually working. And now, if I say nye, then what I get is none. This is how none gets printed out. If I have nye2.txt, then it does the whole thing, and then it eventually says none. Okay, but if you look at the code, then now one of these replaces what? A match, and a none goes into whatever you do for the error. So the propagation of the errors is actually entirely covered by the bind. Now let's see, could we use bind for convert all? I'm not 100% sure actually. Yes, we can actually. Yes, we can. Let's begin by replacing this. Convert all of excess. I simply bind it. Exactly. I bind it, and in this case we don't need anymore. So now fun, and then we have just the argument. And what we do is ret y yes. Oh, this is awesome. Okay. All the brackets. Now this we can simply rename red. And what is a none in our system? What does it represent? Success or failure? So fail. Let fail, just type option of alpha, is simply none. Come on guys, this is hard on material. Even if you're just glazing the surface. Okay, hard on material, but it's still kind of ugly. So, the language offers us, in its immense love for its programmers, facilities to make this yet even prettier. We build an object, which is called the builder, yes,
This is awesome.
which has a member called this.bind, which takes as input an option of alpha. So I'm going to call input. Then it takes as input a function do something, which has type alpha, which goes into option of beta. I wonder if this looks familiar. And it returns an option of beta. And what is this going to do? Why is it complaining? Why is it complaining? Oh, sorry. Sorry.
Yes.
Then we have another member, this dot return, which takes as input an alpha and returns an option of alpha. And this is going to be a ret of x. Yes. Finally, we define an instance nub opt wait, I'm gonna use op. Or yeah. Maybe is an instance of the maybe builder. And now what we can do is encapsulate everything within maybe. All instances of ret becomes return. This becomes do fail, if I'm not mistaken. And this is the prettiest of all. Now instead of having the result of convert all here, because basically the result of convert all is given to the function, what I can do is let bang ys of type list of alpha is equal to convert all. This is not needed anymore because it's going to be automated, and then return y followed by ys. Let's see. Oh no. Okay, there's a shortcut to have fail, which is remember this dot return from, which takes an option of alpha and returns an option of alpha. It's a way to directly return the result of an option, and this is the identity function. Okay, now it's epic. Now, what this thing is doing, if you compare it with all the matches that we had before, this is significantly prettier, and when we do the facelift here, it's going to actually look awesome. The thing is, we say, okay, this is the reference object. Every time we have let bang, which looks like let, it works like let, what this does is it moves this to the left of the bind operator. This becomes the parameter of the do something function, which the compiler builds for us, and the rest of the code is put inside the do something function. Every time we call return, then this method is called. Every time we do return from, we return bang, return from is called. I did keep this as the last lecture because it would put me in a good mood for the holidays. Now, what are these two lines going to turn into? Yes, let bang, so maybe. No, it is certainly going to turn into a let bang, but we need to put the maybe around it. It was not like maybe it's going to turn into a let bang. Okay. So, let bang, now the types I'm leaving just for clarity, they are absolutely not needed, is equal to read all lines. Now the bind operator goes away. Notice that I can de-indent, which is not a bad thing. This becomes yet another let bang, and this becomes return, which also has a stronger precedence, a lower precedence, so I don't even need the brackets. I mean, now look at it. Yes, please. I mean, look at it. Look at what gigantic mesh we had and what it's become. It was a gigantic mesh, but what advantage did it have? It was safe. It was very strong. It was highly correct. Did we lose any power? Did we lose any legibility? I mean, seriously, what we're saying is lines is read all lines. Yeah, duh. Then convert strings to ints, lines convert all becomes ints. Yes, and then what do we return? A sequence.sum of ints. But every one of these steps may fail, and failure will be correctly and gracefully handled. Every step may fail, and how do I know? I know immediately that it may fail. Come on, guys. I'm not seeing the happy expressions that I should be seeing. Do you want to take a break? Then we don't have time for the state model. No. Now, a monad has the general signature, has this signature, which we can't express directly in the language. This is, I think, the only actual serious advantage of Haskell over F#. It's just one, so we ignore it. But the idea is that we build a monad builder, so maybe is a monad. A monad builder, we are given a type M of alpha, which is equal to something. Now this doesn't matter, it's as long as it's a parametric type with one only parameter. So in our case, M was equal to
This
option. M was option. So we start with a type, this is the first ingredient, and then we build a monad builder, and the monad builder has a member, this dot return, which takes as input an alpha and returns an M of alpha. We don't know how it's implemented, so take this as a sort of interface. Then we have member this.bind, which takes as input an input of type M of alpha, a function do something, or K stands for continue, the continuation of the thing, and K takes as input alpha, which goes into M of beta, and the whole thing returns an M of beta. These are the three ingredients. So M, which is called the monadic type, bind, the bind function, and return, the return function. A data type, like M of alpha with a single parameter, what does it do with alpha? What does a box do with things? It stores them. So M of alpha, well, imagine M is an option, then does option store an alpha? Sometimes. So that's the point, it sometimes stores an alpha. If M were list, for example, what does a list do with alphas? It stores a bunch of them. How many? We don't know. M could also be a tuple, a pair of int and alpha. Then it stores an alpha and also an integer for, well, whatever, a counter, doesn't matter. And so on. Now what does return do? It takes an object, and what does it do with it?
puts it first.
It puts into the box. M is the box, okay? This is the most common metaphor for the monads, which is also kind of wrong. Oh, I'm going to zoom slightly, actually, for the benefit of the camera. Now bind looks complex, but actually what does it take? A box. How many alphas are in the box? We don't know, okay? But for every alpha, what can we do? We can put it in a new box, okay? So we open the box, we take all the alphas out, we put them neatly onto the ground, then we put every alpha in its own box, transformed. So we take the alpha, we transform it, we turn it into beta, and we put it into a box. How many resulting boxes of betas do we have?
We don't know, but it's the same.
We don't know.
First one.
I don't know, that depends on the monad.
Okay.
But then what do we do with these boxes, of which we have a plenty? We put them into a single box. So these boxes are special. If you put them together, then the sides dissolve and they become a single box. Okay?
It's a box in a box.
No. We don't really put this into a single box. We kind of merge the resulting boxes together in a single box of betas.
It's a magic function.
So let's take this thing and define M of alpha as list of alpha. So list is our box. Now how do I create a box which contains the value x, where the box is a list? Yes? It's not complaining.
It's fine, it's true.
Now, this one, well, so I is a list of alpha, right? You know what? I'm going to replace M with list. Okay. So I have I. I could, for every I, for every element in I could apply function k. So let's do this. Let L prime is equal to for x in I, what is the type of x? Quickly, alpha. So x is alpha, what does k expect as parameter? Alpha, so can I do k of x? Yes. So what is the type of this function of I? So wait a second. Fail with, not implemented. What is the type of y? No, it isn't. No, it isn't. For every element of the list, we return k of the element. List of beta, close enough, but this is the list of beta, but it's a single element of the resulting list.
Yeah.
So it is a list of beta.
Yeah.
So this is list of beta. What do we need to return as a result?
All this merged.
A list of beta,
Yeah.
a single list of beta. So what shall I do with them?
You combine all this.
I shall combine all of them. So list.concat takes as input a list of lists and concats them together. Now, oh, and this is called list builder. Now, let list is an instance of the list builder. Let wow of L1 and L2, which are lists. List. Let bang x equals L1, so this calls bind. Let bang y equals L2. Return x comma y. What does this thing do? The Cartesian product of lists L1 and L2. So let's print it out. Do print fn war of the list from 1 to 10 and the list from 50 to 60. Okay, slightly zoomed, but you can see 150, 151, 152 until 160, then 250, etc. So this is the list of all pairs coming from two lists. We could say that these are more specifically lists of ints. And then we could restrict this. So if x is even and y is not even, then we return x and y. But now it's complaining because it's saying, okay, and if they are not, what do I give back? So we say that the null instance, no, there is a trick actually. For the else case when you don't specify, you can give a zero method which returns not an option, an instance of L. So list of alpha. You can do this only for option and for list, or for things where you can actually meaningfully say I have no result but I can still give a value. Which in this case is the empty list. Now he doesn't complain anymore. And now we have all the pairs where the first element is even and the second element is odd. We could play with this as much as we want. We could, I don't know, add them together. And then now we have a list of all elements and so on. So the point of a monad so far is to simplify the disaggregation and reaggregation of objects that contain values that we need to process according to a fixed pattern. So for the option, the fixed pattern, which is always defined by the bind operator of the monad, the pattern is match. If it's none, give up. If you have a value, give it to the rest of the program, and give back the result. For the list, the idea is that for every element in the input list, we transform the element into a list, we join the list together. Okay? So every element is opened up by the function k, but not necessarily opened up because the function k may very well return an empty list. So it's not going to be an actual result of the final list. And then we join all the things together. So you have typically an unpack phase, this is the 4. The 4 is open the box. Then you look inside the box, you do the various things you want to do with it, and then you merge it together, which is the list.concat here. Plus a bunch of things like return from, 0, etc., which F# documents on MSDN, and you can look for all the helpers. Does this look complex so far? Good. Then actually do take a break because the next one is really hard. No, seriously, take a walk. 5 minutes. Okay, so to go back to the original problem of the memory in the semantics, because that is where we started, and promises must always be respected. I will discuss the concept of passing through a state which may also change. So let's build a new monad. This is the prettiest of them all. A new monad which has the actual parameter, the actual monadic parameter is the alpha, but it also has another parameter which is the sigma, and the sigma is the state. Now this monad represents a computation with state. A computation with state takes the state as input, returns a value of type alpha, but as it gives you the result back, the state may change. How would we represent the fact that the state may change? So yes, I mean, do I just return alpha here? No. I also return the new state. The previous state, forgotten, old, don't care. New state, yeah, that's the one we like. Okay? So return takes as input a value, alpha, and has to return it directly. Encapsulate it into a stateful computation. But does return ever touch the state? Not really. We just want to say, okay, here's the value.
So it stays in return.
The state that we return is the same. So we take a state as, oh yes, sorry, S of R. We take an S, and what we return is x, comma, x, comma, S. X, comma, S. So we are simply building a computation that takes the state, ignores it, and returns the value that we want to return. No?
I'm wondering, because you've got the, first you have a state and a alpha or whatever, and then you return first the alpha and then the state. Does that have any influence or not?
I need to return, so
Yeah,
the state...
but the order in which you return it was...
Yes, absolutely. Yes, I mean, this is a pair. A pair is first an alpha, then a sigma.
Okay.
So, first an...
Yeah, alpha and then sigma.
I mean, what is the type of S? It's obviously sigma. I will write that down.
On the basic leaks.
Yes, otherwise it will break miserably. So this doesn't break, but it's gonna complain that now alpha needs to be equal to sigma. So typically this shows a mistake. Okay, so S is of type sigma, and x comma S is of type alpha times sigma. Okay. Now bind. Bind is interesting. Now we know it has to return an m of beta, and m is a function, right? And the function has an input. So I just started returning the function. The function has an input, which is the state. I'm going to call it S0. And then I need to return something of type beta times S. Okay, so the I parameter, the input monad, what's its type? What's its concrete type? Line 77. Come on, I, defined at line 81. What is its type? Did I actually forget the sigmas? Yes, I did. My apology. These are sigma. All the m's in this case have a sigma. Okay. No fear, it's fixed. Come on, what's the type of I? It's obviously m of sigma alpha, which is then?
Alpha times state.
No, almost. That is what it returns. But I, is it an object or function?
It's a function.
Function.
What do you say?
It's function.
Why? What is its type?
Because it takes the state and returns.
If it takes something and returns something else, then it's a function.
Yes.
So this here means that I is a function that takes one of these as input and returns one of these as values with a new state of type sigma.
Yes.
So do we have here some state that we can give to I as its input?
That's no.
S0. So let y is equal to I, to which we give S0. What is the type of y now?
Alpha times sigma.
Alpha times sigma. So why don't I expand this into y as 1? Where y has type
Alpha.
and S1 has type sigma. Okay, good. Now, what is the full type of k? Its first parameter is
Alpha.
alpha. Its second parameter is
Returns an
it's an m of sigma beta.
Yeah.
So then it takes something else. When I give an alpha to k, what I get is m of sigma beta.
or you give them another sigma.
Then it weights another sigma.
Yeah.
So k takes an alpha, then a sigma, and then it returns
Alpha sigma.
no, not alpha,
Beta.
beta sigma. So let z s2 is equal to k, y s1. What is the type of z?
Beta. Alpha.
No, it is not alpha.
Beta.
Beta. And S2 has type
Sigma.
sigma. Now I need to return a beta and a sigma. Do I have them?
Yes.
They are, sorry,
Y times C.
y has type alpha, but I need to return a beta. Z, comma.
That's no.
Why do I return S2 instead of S1 or S0?
Because you need the latest state that you have.
Because I give back the latest state. I don't just arbitrarily go back in time, okay? Okay, now this is called the state builder. Yes. Let step is equal to state builder. Okay, so I define now a bunch of stateful computations. Get first, which takes as input a state, x and y, and returns x, comma, x and y. Is this compatible with the definition of state? This is sigma, this is alpha, and this is sigma. Get second, this is sigma, this is alpha, this is sigma. Now, set first, it takes x prime, x comma y, it returns nothing as a result, but it changes the state. How would you guess? Yes? X prime and
Why?
and y. Set second takes y prime, returns no result, and the new state is x y prime. Okay? So what we've built is basically a 2-slot memory. This is literally a 2-slot memory. Now let y prime, which is state, let bang a is equal to get first. Then let bang underscore is equal to, or unit, is equal to set first a plus 5. Let bang b is get second. Let unit is equal to set second with the a times b plus 1. Return, nothing. Okay. So what does this program do? Just read it out loud. It is fairly intuitive, right?
That's the first state.
Yes, it gets the first, then
It sets first state to something else.
to what? What does it change? The first or the second location? Yes,
And then it gets the second state, and then it sets the second state to something.
the second element of the
Yeah,
state.
this,
Okay,
but then you would get the second state is, or the state you have to change values, right?
yes. Now we do y prime, we give it to the generic print. But wait a second, what's the type of y prime? Oh no! Oh, it's gonna be here for 5 minutes. Oh, well, you have time to think.
But it's
Probably gonna have to kill it.
no, but it's so young.
Point is, y prime. Come on, what's its type? Its type. It's the monadic type. And the monadic type was?
What was sigma?
No. Sigma goes into alpha sigma. Yes. Oh, nice. Now the alpha is the last return. So this is sigma goes into alpha sigma. But what is alpha? No, sorry, what is sigma? It's the type of the state, right? What is the type of the state in our case? And another integer. So sigma in this case is int times int. So I can throw this away as well. And what is alpha? No, it isn't. It is the thing we return. So it is, no, it is not nothing. It is unit. Yes. So this is the monadic state. So, oh, I can actually also take this away, as a matter of fact, because it's not needed. So, what does y prime need to be able to give us something meaningful? The initial state, yes. I'm gonna give it 10 and 2. What do I get as a result?
15 and 21.
Sorry?
15, 21. Or what? No.
15, 21, but nah, not entirely. Almost, that is the right hand side.
It should be units and
Unit and
10.
15. I think 15 and 21. It is and 51. 21. No, 21. Let's run it. Unit, 15, 21.
Because the unit is because you don't return it.
The unit is because no, because I am literally returning unit.
Yeah, that's what I meant. Yeah. So if you return something else.
Yes,
it will- yeah.
exactly.
Yeah.
Now, when a computation returns unit, there is a shortened variation of bind, which is called combine, which is entirely for prettiness reasons. So if this is unit, then if I remember correctly, yes, this is how it works. This is unit. We can basically ignore the y. Hope I'm not making any stupid mistakes. Y is unit. So basically, if the first one doesn't return anything relevant, then we just skip it. And instead of writing let bang, we can write do bang. Which makes it slightly prettier. Slightly, it was prettier than it. Okay, now, one nice thing about monads is that they can be combined with each other. So, given the definitions of monads that we have so far, for example, let's pick this one, and let's pick this other one that was list of alpha, or this other one that was option of alpha. We could build a new combined monad, for example, state option, which may occasionally return an option. Now, what is cute about this one, for a small enough value of cute, because this is actually terrifying if you seriously think about it. What is interesting about this one is that basically what you have is the binding of the maybe monad within the binding of the state monad. It really becomes, I'm not going to show this now because that would simply be cruel. But the point is, if you write it down and you know the signature of bind and return, then it kind of looks like there is only one way to make all the pieces fit together. As you put all these things together, you could even have something like this. A list of results, some of which may be failure. And then you would have the binding of the maybe monad within the binding of the list monad, within the binding of the return of the state monad. And then what you get is the power to build full-blown interpreters entirely within your language, and the client programs will look like this. Will still look like this. Okay? So, do you have any questions?
Can you please stop?
Besides, can you please? This is not a question. Okay, see you at the practicum in 2 hours. Thank you very much.